parallel combination of capacitors. In this diagram, between A and B, three capacitors C1, C2, C3 are connected in parallel combination, and plus Q be the given be the positive charge which is given to the point A, and that charge Q will be distributed in the capacitor C1, C2, C3 as magnitude Q1, Q2 and Q3, and V is the potential difference between A and B. Let three capacitors of capacitances C1, C2 and C3 be connected in parallel combination between the 2 points A and B, in parallel combination between the 2 points A and B. Between the 2 points A and B. Plus Q be the charge which is given to the point A, be the charge, positive charge, plus Q be the charge given to the point A. Or to the point A, Q1, Q2 and Q3 be the amount of charge, which are distributed to the capacitors C1, C2 and C3 respectively. Here amount of charges will be different. Q1, Q2, Q3 are different, amount of charges across the capacitors are different, but potential difference will be same. But the potential difference under bracket V will be same. The potential difference under bracket V will be same across all the capacitors across the plates of the capacitors, plates of the three capacitors C1, C2 and C3. Now Q1, Q2, Q3 are the different charges across the capacitors, but potential difference will be same. V is the potential difference across the capacitor C1, V is also the potential difference across the capacitor C2, and V is the same potential difference will be acting, that is V will be acting across the capacitor C3. Now what are the formula of amount of charges across the capacitors? Q1 equals C1V, Q2 equals C2V and Q3 equal C3V. Assuming potential difference across the capacitors will be same. Therefore, total charge is given by the total charge on this parallel combination of capacitors is given by Q equal Q1 plus Q2 plus Q3. Q equal Q1 plus Q2 plus Q3. Now putting the expression of Q1, Q2, Q3, we get what? C1 plus C2 plus C3 bracket closed into V. So finally we get the expression of total charge Q as C1 plus C2 plus C3 dot V. This is equation 1. This is equation 1. Now between the 2 points A and B, 3 capacitors C1, C2, C3 are replaced by a single capacitor of capacitance Cp. Last plate and the right hand plate will be connected to earth. Between A and B, equivalent capacitance is Cp. This plate has positive charge and the other plate will have induced negative charge, and Q be the charge given to the capacitor, and same potential difference V will be acting across the plates of this capacitor. If these three capacitors C1, C2 and C3 are replaced by a single capacitor or by an equivalent capacitor of capacitance Cs, equivalent capacitor of capacitance Cs, not Cs, it should be Cp, between the 2 points A and B, between the 2 points A and B, such that the single capacitor Cp, the single capacitor Cp would acquire the same charge Q, would acquire the same total charge Q under the same potential difference, V, under the same potential difference V. Therefore, in this case, amount of total charge Q will be Cp dot V, Q equal Cp dot V. This is equation 2. This is the amount of charge given to the equivalent capacitor Cp in parallel combination. Q equals Cp dot V, which is equation 2. Comparing equation 1 and 2. Comparing equation 1 and 2. We get Cp dot V equal C1 plus C2 plus C3 bracket closed into V. So V and V will cancel out and we get Cp as C1 plus C2 plus C3. Equivalent capacitance Cp will be equal C1 plus C2 plus C3. So this is equivalent capacitance. Equivalent capacitance of the parallel combination of three capacitors, Cp is equal C1 plus C2 plus C3. Now we can move to the next page. Additional information. For a parallel combination of n number of capacitors. For a parallel combination of n number of capacitors. N number of capacitors. Of capacitances C1, C2, C3, Cn. C1, C2, C3, Cn. What will be the expression of equivalent capacitance? Cp will be equal to C1 plus C2 plus C3 plus plus Cn. Therefore, Cp equal summation Ci, I starts from 1 to n. This is the expression of equivalent capacitance of a parallel combination of n number of capacitors. Now another additional information. We know that in parallel combination equivalent capacitance is Cp equals C1 plus C2 plus C3 plus plus Cn. Now we can assume that let C1 be the largest or greatest capacitance and C2 plus C3 plus plus Cn equal x. Therefore, Cp equal C1 plus C2 plus Cp equals C1 plus x. Therefore, Cp greater than C1 as x is positive. Hence, we can say that the equivalent capacitance C1 be the largest capacitance. The equivalent capacitance of parallel combination of capacitors is given by is greater than the largest capacitor or capacitance. That means Cp is greater than C1. The equivalent capacitance of the parallel combination of capacitors is greater than the largest capacitor or largest capacitance. Is greater than the capacitance of largest capacitor. That means correction, the equivalent capacitance of a parallel combination of capacitors is greater than the greatest capacitance. Cp is greater than C1. That means equivalent capacitance is greater than the greatest capacitance.